Hi, everyone. Thanks for joining. I think we'll get started here in a couple minutes, give people a couple of minutes to filter in here. Okay, so it's a few minutes after 7 a.m. for me. I don't know about the rest of you. It is bright and early for me. But why don't we get started? So today, welcome to the second day of the gem5 workshop. So today is going to be a little bit different. Rather than hearing talks, this is going to be more of a town hall. Really, my goal here is I want the whole community to be able to speak and be able to hear everybody in the community. So brief agenda for today. So I'm going to try to keep this to a short 2 hours. So first, I'm going to give a quick announcement of Gem 520. That'll be about 15-20 minutes. And then I kind of want to turn it over to the community to give feedback. We want to hear from people. You hear a lot from me and a lot from the other main developers, but we want to hear from everybody in the community. So that we'd start with what everybody loves to do, which is complain. So I'd love to hear some major pain points that you're experiencing with Gem 5 or just general feedback. Then I definitely want to spend a little bit of time talking about the new features or new models that both you find important and would like to see in Gem 5, and also that you're currently working on and are thinking about including in Gem 5 or upstreaming at some point. So I have some ideas here, but we can kind of see where this takes us. If we have some time, I'd like to hear about workloads, what workloads the community thinks is important to have good support for in Gem 5. And then we'll do a quick wrap up at the end. Okay, so with that, let me jump in and start talking about Gem 520. So I'm really excited about the gem520 release. This really is a new era for Gem5. We are changing a lot of our processes right now, changing the way Gem5 development works and the way just the whole community works, and really transitioning from what was a small research project into a truly community-driven tool, which can be used within the architecture community and beyond. So to quickly introduce myself, I'm Jason Lowe-Power. I kind of wear two hats. I'm an assistant professor at the University of California, Davis, and also the project management committee chair of Gem5. So today I'm going to be wearing my Gem5 hat and not my computer architecture researcher hat. Okay, so quick outline for this talk. So first I'm going to give a little bit of an overview of Gem5's past and what's going on with Gem5 today, or has been going on in the past 9 years leading up to today. And then I'm going to talk about the future of Gem5. So I'm going to give what is my vision for Gem5, but this is just mine. I would like to hear what your vision for Gem5 is as well. Talk a little bit about some of the cool things that we're thinking about doing over the next few months. And then what today is all about is your input. I want to hear what your vision for Gem5 is and where you see Gem5 going in the future. What you think is exciting to work on for Gem5. Okay, so a brief history lesson. I'm sure many of you know this. But so Gem5 was the combination of two simulators. M5, which was created in Michigan by Steve Reinhardt and his students, principally the late Nate Binkert. So Nate laid an incredible foundation for M5 and Gem5. And as a testament to that foundation, I think that going back, we can look at this slide, which I stole from the M5 tutorial in 2005, so 15 years ago. And we can see that the description of M5 still really does a great job describing Gem5 today. So Gem5 is a framework for event-driven simulation, events, object statistics configuration. And it's a collection of predefined object models. I find this, Nate just had an incredible forward vision to be able to lay this foundation, and that we're still using, and fundamentally it has not changed over these past 15 years. So it was a combination of both M5 and GEMS. GEMS was created at Wisconsin by students of Mark Hill and David Wood. And the focus of GEMS was really on the memory system, specifically caches. So GEMS also had a tutorial at ISCA 15 years ago, which is a slide from here. And I think possibly some of the people on today's Zoom actually gave this tutorial 15 years ago. So GEMS, the core of it was Ruby, which was a cache model and memory. So it models details of cache coherence as well as the internet interconnection network. And we still use all of these tools today, and they're still being actively developed. And so M5 and GEMS was just an amazing base to build Gem5 on top of. And so about 9 years ago, almost exactly 9 years ago, M5 and GEMS were combined into Gem5. These two projects were started about, both of them started around 2000, GEMS a little bit before M5. So in some sense, Gem5 development has been going on for 20 years, and it's 2020, so hence Gem5 20. Okay, so Gem5 today. So in the last 9 years, since Gem5 was released, the Gem5 paper, which was released in 2001 at the same time, has been cited over 3,600 times. Gem5 is has been used a huge amount in the community. And this isn't just like a one-off thing. The use of Gem5 has been growing significantly over time. And it's cited between 500 to 600 times a year now. But what I think is even more exciting isn't the number of people using Gem5, but it's the development of Gem5. This is an incredibly thriving development community. So since the Gem5 release, which I'm calling June 2nd, 2011, because that's when The binary was renamed from M5 to gem5. There have been over 7,000 commits to this repository. And in some years, like in 2018 and 2019, we had over 1,000 commits to the repo. It's like 3 or 4 commits a day. So it's a very thriving community. But even more exciting than the total number of commits is the number of unique contributors. This isn't a small number of people working on this project. No, we've had 250 unique contributors over the past 11 years. And this is growing over time, which is really exciting. And 2020, if we stay on pace, what we've done so far, so this is only 5 months. If we stay on pace, I expect to exceed these numbers this year as well. Okay, so I want to briefly talk about one specific thing in these graphs. So you can kind of notice in 2014, 2015, 2016, things kind of tapering off. And then in 2017, 2018, things took off again. So what happened here? Well, as we saw on the previous slide, the use of gem5 was significantly growing in this time period. But we were still kind of treating gem5 as a grad student research project. And around 2016, 2017, we started taking a concerted effort to make this more of a community-based project. And so we made some improvements in the community, which I think is what kind of turned this corner and started increasing the community. So we did things like move from Mercurial to Git. Developers are more familiar with Git. We moved from review board to Garrett for our code review, which made code review easier. We improved the documentation. So onboarding with gem5 became much easier as well. But what I think is more important than all of these development changes is that we really started transitioning gem5 into a community-based project. We made a new formal governance model, and specifically, we're a meritocratic governance. So anyone can be part of this community and anyone can contribute. So contributions can mean a number of different things, not only just committing code to the repository, but improving documentation as a contribution, asking questions on the users list as a contribution, and even things like attending this town hall is contributing to the gem5 community. So another thing we did was try to formalize some of the community structure. And with that, we made a project management committee, which you see pictured here. Many of them are in this call. And what I want to say here is that the project management committee does not dictate where the project is going, what the project is doing, what gets in and what doesn't get in. The project management committee is really just here from an administrative point of view. We just manage things. Most of our responsibilities are things like the website or putting together workshops like this. We don't have any more power in the community than anybody else does. So we also formalized our contribution guidelines, which made it easier to know how to contribute, what it means to contribute to gem5. And another thing that I'm really excited about more recently, we're starting to get resources from the community at large. So specifically, NSF has made a big investment in gem5, so big, in fact, that we were able to hire 2 full-time developers. So these 2 people pictured here, Bobby Bruce and Hua Nguyen, I'm sure you've started to see emails, especially from Bobby. Hua started a few weeks ago. These 2 are full-time software developers for the gem5 community. They're sitting at UC Davis, but they're not working for my research group. They're working for the gem5 community. We also have resources for our continuous integration that was generously donated by Google as well. Okay, so with that, I'm super excited to announce gem5 version 20. So here's a list of all the people that contributed at some point to gem5 20. This was scraped from Git, so there's a number of other contributors I'm sure I'm missing. So this is the 250 people that are contributed to gem5. And what I was really hoping to announce today was that we're going to have a gem5 20 paper. And so unfortunately, I kind of dropped the ball on this and was not able to complete it in time. There's a lot going on right now for all of us. But soon you'll be seeing an announcement about the gem5 20 paper. Many of you have already gotten emails from me about this. But I'm inviting everybody who's contributed to gem5 to be an author on this paper. So if you have any questions about that, please direct it towards me. So thank you very much for all these people who have contributed to gem5. And thank you all for contributing. So what are the major changes in Gem 520? Well, we now have a release cadence. We're going to be releasing major versions of Gem 5 once every 4 months. That's our current plan. This is subject to change. I'd love to hear your input on how frequently you expect things to be, how frequently you would like to see new versions of Gem 5. With each of these releases, we're going to have release notes, which explains all the changes from previous releases. You can see an example of this in the current Gem 5 repository. And I think I have a blog post talking about the release notes as well. We have well-defined APIs in Gem 5. Well, we're working to have well-defined APIs in Gem 5. These APIs are going to be stable. And all of the changes to the APIs, because APIs have to change. We want to improve the simulator, so our APIs will change. But these changes will be explained in the release notes, and it will explain how to upgrade from one version to another in a straightforward way. And if you use Gem 5 for research, from now on, you should be using the master branch, not the development branch. The master branch is stable. So this is where, so if you check out Gem 5 master right now, you'll get Gem 5 version 20. And you can cite this in your papers. You can say, I use Gem 5 version 21.2 with these changes on top of it. And so I think this is going to make it much easier, both for reviewers and future readers of your papers to know what the baselines were that you used. And we'll be backporting bug fixes from the development branch into these major releases between each major release. In fact, we've already done this. Within hours of releasing Gem 520, we already had a bug that we needed to backport. Okay, so with that, I want to shift into talking about my future, the future vision of Gem 5. So again, I'm going to talk about my personal future vision, but really what I want to hear is about your future vision as well. Okay, so I would say most computer architecture simulators are really focused on the microarchitecture and ISA interaction. But computer systems research is really about these cross-stack interactions, especially today. And I think Gem 5 is the tool that is best suited for doing this kind of cross-stack research. At the same time, we're seeing this new agile hardware development methodology as well as open source hardware. And I think Gem 5 can be the open source tool for this early C++ prototype and design phase. And so I think that Gem 5 can be used much more than it's being used today. So my vision is that anyone, even a non-computer architect, can download and use Gem 5. My vision is that it can be used for cross-stack research. That if you want to do research that changes the kernel, changes the runtime, changes the hardware all at the same time, Gem 5 is your go-to tool. My vision is that we're going to be able to run full machine learning stacks, TensorFlow with GPUs, et cetera, full AR, VR stacks, or what other emerging application happens to come out in the next few years. That Gem 5 will be the go-to tool for this. And what's really exciting is we're really close to this. This is what Gem 5 was designed for. We just have a few rough edges that kind of makes this difficult. So this vision isn't a 10-year vision for Gem 5. It's really like a 1 or 2 year vision. I think we're almost there. So I want to talk about one thing that we're going to be working on here at UC Davis over the next few months that's going to smooth out some of these rough edges. And this is known good configurations. So what do you normally want to do with a simulator? Well, you want to take some baseline, add a new feature, and see if that new feature improves performance. You might want to take a desktop baseline, a laptop baseline, or a mobile baseline, or something else, and then build on top of that. So we will provide these baselines for you as known good configurations. These baselines are going to be tested at every Gem 5 release to make sure they're working. And we're also going to take community feedback to be able to add both workloads and new kinds of configurations as well. This allows researchers to concentrate on just one part of the system, rather than having to figure out what the width of the algo border CPU should be, as well as the size of the caches and the number of ports to the L1 cache. You can concentrate on the part of the system you care about. This will also improve methodology sections in papers. You can say, I use Gem 5 version 22.1 with the desktop known good configuration as my baseline. That's all you'll need to say. and everybody in the community will know what you're talking about. This will also give non-computer architects a starting point. You know, if you're a networking researcher or an operating system researcher, getting started with Gem5 is incredibly difficult. But this will say, well, if you use this Knowngood configuration, you're going to get some reasonable results. So what I see is it's going to be as simple as saying, from gem5.model library, import desktop system, and you're going to get performance that is somewhat correlated to, say, an Intel Core i7. So with this, we're going to have a Gem5 status and performance board. And so we're going to be broadcasting, advertising all of the details of these configurations as well as their performance. This is going to show what works and what doesn't. It's going to show comparisons between different configurations, comparisons to hardware, and also it will be updated on every Gem5 release for all of the Knowngood configurations. So there's already a version of this that we're working on, which is on the Gem5 website, which I'll show you real fast. So if you go to the Gem5 website and go over to documentation, there's a working status of benchmarks page now. This is a work in progress, but this currently shows for Gem520 a few different benchmarks that we have put in the Gem5 resources repository and what their status is. So this currently is just showing whether it works or not, but we're going to be expanding this to talk about the performance both in the simulator and of the simulator. So for instance, here we have the boot tests. So does Gem5 boot Linux? And this is for a variety of different memory systems, different numbers of CPUs, and different CPU models. And so from this, we can kind of see that there's a lot of problems with the O3 CPU. So this gives us a hint that we might need to dig into this and figure out what's going on here. And this is one of the things we'll be working on over the summer. So we also have other kinds of benchmarks as well. So this is the NAS parallel benchmarks, which we've evaluated on a smaller subset of CPUs and memory systems. We also have Parsec available, as well as Spec 2006 and Spec 2017. All of these workloads, the disk images, the kernels, the inputs, everything is available on the Gem5 website, at least those that we can distribute. We can't distribute Spec, unfortunately, but if we are distributing all of the scripts to get it going, and so as long as you have a Spec ISO, it's almost a single button press push to get these results. Okay, so a couple of the things that's going to be happening that we are currently planning on with Gem5. So I briefly talked about this before. We're going to be formalizing our APIs. This will give us stability across versions, as well as simplify integrating things with Gem5. So if you want to integrate your simulator with Gem5, by having these formal APIs, Gem5 will no longer be a moving target. We're going to enable, this will also enable model and code sharing much more easily between research groups, because again, Gem5 won't be a moving target. We're also working on testing. This is, I think, one of the biggest ways to improve Gem5 is by improving the testing. We're going to be adding more unit tests and also make testing faster, make it easier to run our tests, as well as better test coverage. But most importantly, I want to hear from you all. What are your ideas? Where do you want to see Gem5 going? What is your vision for the future? So the other thing we're going to be working on a lot is strengthening the Gem5 community. So I really want to broaden the scope of the Gem5 community to both other computer systems communities, as well as broaden Gem5 within the computer architecture community. So one of the things we're doing with this is with this these resources from NSF, part of Bobby's and Hua's job is to be a community code shepherd. So if you need help integrating your code into Gem5, if you need to learn how integrating your code works, how to upstream your code, what the Gem5 style is, how to improve your code so it can be integrated more easily, this is part of their job, and you can reach out to Bobby or Hua, and they will help you do this. There's going to be a Learning Gem5 online course, more details to come soon. Gem5 Announce is a good place to find out details like this. I want to increase the transparency in the community. So it's really important to me that this community is fully transparent. You've heard me use the word community a lot today, and that's because it's really important to me. that we are a community around this tool. And with that, I also wanted to broaden the participation and make gem5 as inclusive and diverse of a community as possible. And other ideas that we're thinking about with this is, do we want some kind of gem5 low latency chat? Should we do a Gitter? I know some open source projects use this, or a Slack, IRC, something like gem5 office hours. I'm getting pretty good at this remote office hour thing. Should we do like 1 or 2 hours a month where I or other gem5 developers are available? More frequent town halls. We'll kind of see how this goes over the next hour and a half or so, but maybe we'll try to do this more frequently. I guess as a side note, it's kind of cool that this is virtual, in that I think we're going to have a lot more participation in this. I'm kind of excited about that, to see how this virtual town hall goes. And if it goes well, I definitely foresee us doing this in the future. And again, I'd love to hear your ideas. What are your ideas in strengthening the community? How do you think we can improve the gem5 community so that we're all better together? Okay, and with that, I'm going to conclude this talk, which was a little bit longer than I kind of planned on. But I think you can tell I'm really excited about the future of gem5. And I feel like we're really hitting a turning point. So gem5 version 20 is going to be a new era for gem5. And I'm really excited to see what's going to happen. So with that, I'll stop there. I'll take a few questions about this if people have it, and then we can transition into the town hall. So for any questions that you have about this, please use either the Zoom chat, or I think we're streaming on YouTube as well, and I'll be monitoring the YouTube chat as well. So thank you very much for your time. I'm happy to take questions. I'm looking a way to pull up the chat right now. I'll give people a minute. Here we are. A couple of questions. So first, Andreas Sandberg asks, which architecture are you using for the status page? Is that just x86 or a mix of architectures? Right now, this is just x86, although there's no reason for it to be only that. This is just what our group has been working on. We need to kind of formalize the way we're doing this, and we're working on this with our group to make it easier for other people to contribute. And we would love it, especially if ARM contributed some similar things for the ARM ISA and the workloads that you all have working. So Dan asks, so between the major release cadence of 4 months, how often will similar smaller releases happen? We currently don't have any plans for minor releases. Right now, we've had 2 examples. In the 2 weeks since we released gem520, we've had 2 examples of hot fixes where we found major bugs that we needed to get in, and that we just immediately merged in to the major, to the master branch and bumped the major release version. We don't have any plans for minor releases right now. There was a conversation about doing 1 major release a year and then 3 minor releases. And we kind of decided for now to just do major releases, but we could go to that other model as well. I'd love to hear what other people in the community think about that. Yes, and Andrea says that that explains why Classic doesn't work with x86. That's exactly right. In fact, I'm not sure if we even tested that. We just kind of know it doesn't work. It's on the to-do list. Let's see, as a feedback, Giacomo says, I think we need to keep track of simulator performance, not only between releases, but on a per commit basis to make sure the developers can properly amend fix their commits. I agree. I'm not sure if you're talking about the performance of the simulator or the simulated performance, but both of them are important to keep track of, and that's something on our to-do list. Yeah, so Adarsh asks, are there any plans to validate, correlate gem5 against real hardware, like the working status page? Absolutely. So this is what we're going to be working on over the summer. Crossing our fingers, we're going to be able to do this by gem5 20.1, which will be released in August or September. But the goal is these known good configurations will be somewhat correlated to real hardware. And we will publish the correlations on the website in a similar way. Let's see, Mateo says, it's a great vision to think about full ML stacks, TensorFlow, and possibly even more complex stacks running on gem5. However, gem5 is a sequential application, and its performance when running complex workloads and OSs is somewhat limited. For instance, it can take 2 weeks to run a limited-based application. 2 weeks to run for a Linux-based reasonable multi-threaded application running for even just a piece of a second in simulated time. Are we going to see a parallel gem5 version on the stable branch at anytime soon? Anytime soon, I think I can solidly say no. Simulator performance is really important. What I would expect to see, but I guess it depends on the community. This is not something that I am personally working on or have seen other people work on. There's been fits and bouts of this trying to parallelize gem5 over the years, but nothing has really come of it. That said, simulator performance is really important, and one of the things that's on my short-term to-do list is getting better support and built-in support for statistical simulation. So we can do sampled simulation, which I think will get us somewhat there, although it's not perfect. There's downsides. Okay, a couple more questions, and then I think we'll try to move into the town hall portion. So Manu asks, any plans to support the latest Android releases in FS mode? Great question. I think that's a really good piece of feedback for what we should be doing, looking at in terms of workloads. It takes quite a bit of effort to bring up a new version of Android, but I don't see, that would be a really good community contribution. And I hope what we can do is by using some of the stuff we're working on, like gem5 art and the gem5 resources, we can make it easier to keep track of gem5 instead of having to redo all of the work every single time for something like bringing up Android. Daniel asks, who should I talk to about fixing some of the Spec 2006 build errors? There is let's see. The best way is probably fixing it on the gem5 resources repo. So I don't know if it's committed right now, but there are patch sets on gem5 resources which have all these changes that we need for spec. And so that would probably be the best way to contribute there, Daniel. Okay, 2 more and then we'll move on. So Faustin asks, I use gem5 to simulate the collection of cache coherence. However, the output stats.txt contains many parameters. What are the right parameters in stat.txt reflecting the overall number of data cache misses, hits, reads, and writes, and the total number of memory references? Great question. I'm going to say that probably depends. Generally, stats is something I would love to see improved sooner rather than later. I agree that it's kind of confusing. I don't have an immediate answer for you. This would be a great thing to bring up in something like a gem5 office hours or in the gem5 users mailing list. Okay, and Huya asks, do you have any plans to make Ruby protocols available in a single gem5 binary? No short-term plans, although that is something I would also really like to see. Another thing that it would be really great to see, contributions from the community. Okay, great. So thank you all very much for your attention there, and thank you for all your questions. Now I want to shift over and move on to the town hall version. So we're going to try something a little bit different. I'm going to give up my presenter rights. And I kind of want to, let's see what happens if we allow anybody to come on and speak. So I think to do this, what we'll do is, if you can raise your hand in Zoom, I will call on people one at a time to kind of give their feedback. So let's see how this goes. Let's start with the major pain points. So what kinds of things, how are you using gem5 in your research? How are you developing with gem5? And what are the problems you're running into, or things that you think we can improve? Or even better, what are we doing well and we should keep doing? So we'll start with that. Let me give up my screen share. So if you can raise your hand, I'll call on you, and it would be best if you could turn on your video and audio. That should be enabled for everybody. I feel like we need some kind of like elevator music or something here. I find it hard to believe that nobody has any pain points. Maybe they just don't want to discuss it. If you would rather write your message in chat, that will work fine as well. Okay, Daniel, go ahead, please. Yeah, go.
Okay, can you hear me?
You are very quiet.
1 second. Is it better now? Andres, you can go ahead if you prefer. I'll try to get this fixed.
I think we can hear you a little bit better now. I think that's maybe just be closer to the microphone.
It's inside my mouth. Okay, testing now. Is it better?
Yes.
Okay, so overall, when I use it, I find there are issues, but there are issues as there would always be. So my major pain points are mostly testing, because when you do an implementation and in the end, after 2 months, you're about to publish results, you find a bug. That's a pain because you didn't have a proper testing infrastructure, and that's an issue of the sim object. I know Gabe's starting to look at that, so that's nice. And another thing that's a pain point is something that I forgot. Wait. Okay, templates. The template support in Python is very limited, and I would like to make some things more general, but it's very hard when there's so much limitation. So for example, on the compressors, I'm thinking about retreating on my template approach so that I can use sim objects. It's quite a pain not being able to use templates there.
Gotcha. So a couple of quick questions diving in there. So on the testing, after working on it 2 months and then finding a test, is that finding a bug? Is that a bug in your changes, or is that a bug in Gem5?
Who do you think? Of course, it's mine.
No, I actually thought it was going to be the other way around.
No.
Okay, I think so that's great. Yeah, I think providing a better framework to be able to write tests for your models is something important.
So one thing I would like to see related to that is a sort of test harness for sim objects, so we can stimulate the PIO interfaces of devices or the memory ports from Python and write more directed tests for things like caches or peripherals. It's certainly something that would make my life easier in some cases. And I suspect in Daniel's case, some of that testing could probably be done by just exporting methods to Python and then instantiating a small system and just poking the sim object from the Python script.
yes, but what I was looking for was unit testing.
Ah, yeah. That would be
That's
nice.
the keyword.
Yeah.
Yeah, so I think that's important. So can you talk a little bit more about the template thing? So is that just that sim objects don't support templates very well? Or is it something deeper than that?
Yes, that's just that the Python version, the parameterizing of the Python objects doesn't support templates. And I know it's very complex to edit in a full state. And how do we choose what parts of templates in C++ are we going to support? How do we support it properly? I know there's a lot of discussion involved in that, but overall, having a little bit more than this minimal support that we have would be beneficial, I think.
I think that's good feedback. I think that's something that maybe if you wanted to write up a proposal or like an example of how you see templates being used, that's something we might be able to start moving towards. I definitely see what you're talking about and think that could be a good thing to do. Yeah. Okay, other people? Other pain points? So I guess I'll briefly talk about what I think was my biggest pain point when I used gem5 in my research. And this was the fact that I would run simulations, get results, go on to something else for a month or two, maybe submit the paper, and then come back, have reviews, and then try to rerun the results and not be able to get the same thing. Like, for the life of me, I could not figure out what configurations I had used previously or what workloads I had used, what compiler I had used to be able to generate the same results. And this bit me multiple times during my PhD. And so because of that, we've been working on creating what we're calling gem5 art. There was a talk about this yesterday to try to make it easier to document all of the inputs for a particular experiment. So I kind of hope that that's going to help smooth that over. Gem5 Art is an open source project now. It is not integrated into Gem5 yet, but if we start to see some pickup from the community and if the community is interested in putting that in the main Gem5 repository, we would be happy to do that. Yes, Faustin, please. By the way, am I saying your name correctly?
Yeah, it's right.
Great.
Yeah, thank you. As I posted in the question, when I use gem5, the main question is that the output has many parameters, and I couldn't figure out what is really the right numbers of cache misses and hit and reads that I could use, because I can see the same number, having the same number, but then the names are so different, and I can found like 5 parameters describing almost the same thing, and figuring out what is the right one among those, it's really hard for me. And the other bottleneck that I found is when I try to use the gem5 on matrix example, and with the matrix example, I had like different versions of matrix matpry, which can use different CPUs or just threads. And then when I need to use more than one thread, if I don't specify the number of threads from my application, then gem5 confuses with division per 0, and it's bring me an error, the so-called panic error that I don't know how to fix. And for instance, I just have to fix the specific number and say if the multiply is this version, then use 4 threads or a kind of. In fact, that's the bottleneck. And I think I really need the help about the figuring out which numbers, because if I compare with other tools which can, for instance, give out the cache coherence, like InterVTune or these other tools which do it on the real targets. I need, in fact, to compare. And I'm designing my own simulator as well, and I need to compare the numbers so far with the one with gem5 to see if they are really somehow closer. And it's really hard for me to know which exact parameter should I look on this.
Yeah. So
Yeah.
there's a couple of things there that I hear, and I want to bring up a little bit more broadly. So one is documentation needs to be improved. It sounds to me like a lot of this is that it's just not well documented what these statistics are, or it's not well documented how to say the number of threads in a particular configuration. And so that will definitely, we will definitely be working on that and try to improve that documentation. For specific questions, definitely ask gem5 users, and someone will get back to you. The other thing I wanted, that I think you brought up, which is something I'd like to bring up with the broader community, is the statistics output more generally. So right now, we essentially just have this ugly flat text file, which mostly uses the, like we try to have these names be as concise as possible because they're variable names. So putting documentation there is, we try not to put that much documentation because then it bloats the text file. I think Ciro had a recent commit trying to get rid of all that. So I personally think it's important to improve the statistics output. What do others think? And if we were to start focusing on improving the statistics, as a couple of questions. One, what improvements would you like to see? And also, is anybody currently working on this? Yeah, Dan.
Hi. So something that I've been doing recently, I haven't changed the statistics output necessarily, but I've taken what we have already and I just parse it down, and I use pandas. So it's this Python library that some of you might be familiar with. It's essentially Excel in Python, and we already integrate. We already use Python, so it's super easy. And I found that doing that and kind of selecting ahead of time the statistics that I'm interested in, and outputting it to a file that uses basically outputting it to a CSV and then using pandas to parse it is a much more effective way of dealing with the statistics, and makes it automated, and you don't have to copy the whole stats file out and reparse it every time. So I'd really recommend integrating pandas into the mainline statistics management system in gem5.
I'd love to see that also. Yeah.
Sure. Yeah.
It's good to hear that other people are also doing the same kind of thing. My personal frustration with that is it feels like every time I add a new statistic or every time I do a new experiment, I have to completely rewrite my parsing to go from gem5 to pandas. I probably have 30 different parsers lying around for that.
So you rewrite, like when you add a statistic in gem5, you have to rewrite well, yeah, I mean, it's kind of like experiment dependent, isn't it?
Exactly, which is really frustrating.
Yeah.
Andreas, did you want to put in? I know that you've been doing stats improvements. The HDFS stuff that you added is a really good step in that direction.
Yeah, and there have been a few other changes as well. Like you can now dump the stats for a subset of the simulator, not just the whole thing. So if you are performing experiments where you only really care about, say, the caches, you can dump the stats for a specific object. That's quite helpful, and the HDF5 files can be helpful, especially for long-running experiments where you want a time series of data. and those go straight into Python. It's really easy to work with. But for other use cases, I suspect we should maybe consider adding a native JSON output format. And that should be really straightforward now.
So your changes with the subsets now make stats truly a nested format and no longer this weird, everything's flat text. No
Yeah. Yes. The only problem is that we haven't converted all of the objects in gem5, but I think most of the memory system has been converted to the new system, so we expose the hierarchy. So those objects you can request stat dumps for. I don't think we've done it for the CPUs yet.
That sounds like a fabulous first-time project in Gem5 to convert the stats that haven't been converted to the new style.
Yeah, so it's for anyone who wants to do that, then just have a look at the like the com monitor. That's a fairly small component. It's been rewritten using the new stat framework and should be fairly easy to understand.
Yeah, especially to go one component at a time. That would be a really great first-time project. Bobby's taking notes. If you could write it down to put that on Jira as a first-time issue, which, by the way, I guess I'll bring that up now. For those of you looking for ways to start contributing, on our Jira, we've tagged a bunch of issues as good first-time issues. So if you click on that, you'll get a list of Jira issues, which we think would be good as a starting point. And so you can just comment there and say, I want to help doing this. Can you give me some pointers? And Bobby or I or somebody else will jump in and help you get started. Any other thoughts about the statistics?
Just quickly, would it make sense to add a stats parser to the main gem5 repo? I suspect all of us have our own custom stat parsers.
Yes.
Okay.
Nikos, did you want to say something about stats?
Yeah, I also want to add, I think it would be good, like at some point in the future, to also see stats being part of our testing framework, of our regressions. It would be nice to have like those trivial changes that make no change to stats, you know, as being like a very easy thing to accept. I know like it's something that we tried in the past and it's not an easy task, but as a future vision, I think it's going to be in the right direction.
Yeah, I think it was not an easy task before because the stats file was not nested, so it was really hard to check one stat.
Yeah.
It was difficult to parse because we didn't have a general parser for it. And so I think that's, hopefully if we do these things, it'll make it easier to do that.
Sure.
Great point. So it looks like Andreas is the stats parser he has on GitHub. That looks like it could be really useful for the community. Other thoughts on stats? I think that this is something that was important to talk about. Yeah, Dan.
It's just something that I've run into that I've wanted that I haven't really thought about how to implement or really even tried, but it would be nice to be able to track statistics for like a region of memory, or you know, like if you're tracking miss rates, maybe track miss rates for a particular array that you've chosen within a benchmark or something like that. It might help with like, you know, analyzing, sharing, and things like that. But I don't know how I would go about implementing that necessarily, but it's just an idea.
I think that would actually be quite tricky with the current stat system because, well, actually, you would probably know the ranges when you instantiate the objects, wouldn't you?
Yeah, and I mean, there are ways of, you know, maybe you could register the physical address inside the benchmark. You call a pseudo instruction a system call, and then you register that physical address with a stat parser internally, and it does something from there.
So I think you would probably have to do something bespoke for the objects where you want to track specific addresses. But But in terms of the stat machinery, I think it's probably going to be a lot easier with the new system because we can define groups of stats and instantiate that group multiple times with slightly different names. So you could have named ranges and associate the stat group with that range.
Is the new version already in the? Is that already in the
yeah.
20 or?
It's in the current release branch. It's a prerequisite for HTML5 support.
Yeah, and specifically for memory, I think you could probably design something like the something like a bridge which tracks these stats for you, and just like plop it down wherever you need to.
Right. Yeah.
Okay. Cool. Thank you, everybody. So let's see. Getting back to some of the other questions. Linja asked a question, or said, raising their hand.
Hi, can you hear me? So my question or comment is mainly about the code format. So it bothers me sometimes, especially when I try to commit something, the built-in code format checking won't let me commit. And also working in the LVM community, so they have good code formatting tool, especially for C, C++. So I wonder if we can adopt a standard like format and code format and adopt like maybe the clan format instead of the current format. That'll be, and there's a tool like to automatically format the code. So that'll be much easier, I think, for everyone to code.
Yeah, so I think to try to repeat that, you were breaking up a little bit there. You were saying that it's a little annoying that you can't commit your code because it doesn't match the style, that it would be nice to have something to automatically format the code.
Yeah, and the style is actually not consistent in different parts of the code. So some places mess up a little bit. So if there's a standard tool everyone can use, then I think it will be much more consistent in the code base.
Yeah, go ahead, Andres.
I think we discussed this in the mailing list probably 2 or 3 years ago. And I know that there have been a couple of Clang format files kicking around various places for gem5. At the time, the issue was that Clang format doesn't support all of the slightly quirky aspects of the gem5 style guide. I think the main issue was something around like half indents in keywords and classes, something like that. I think we could probably come up with a Clang format configuration that roughly matches the current style. But we should probably consider changing the style guide to be more similar to a common style like the Google style, for example, which is pretty close to what gem5 does already. And that would give us some more benefits from Clang format, like we would have a much more robust way of testing for style violations. The current Python scripts are a bit annoying to maintain.
That's an understatement. A quick straw poll. So in Zoom, if you click the participants button, you have yes check mark and no check mark. Would you be for changing the gem5 style, which will require touching a significant amount of files just for style things, make merges kind of annoying, but could make it a lot easier to automatically format code, and also be more clear with what our style is. So I'll give that a minute. So we have a whopping 11 out of 50 people who voted. Anybody else have an opinion? Oh, now we only have 10. Okay, so that was not a very good use of Zoom there. there's not overwhelming support, or it's not overwhelmingly negative. We'll put it that way. We'll put it on the list of things to think about doing over the next few months. I like the idea personally. So
I think if we do it, we could probably do it in a fairly lightweight way and keep most of the current style. And it would be, I think the only changes would be in header files, pretty much. From what I can remember, I looked at this many years ago.
Yeah, it's mostly that stupid public, private, protected thing.
Yeah.
I think would be the biggest change. Okay, let's see. So Rubel asked if they could put the question thought in chat, which is absolutely fine. So please feel free to do that. And then Brad raised his hand. When we get the chance, I'd like to get back to testing. It relates to the current claim discussion as well. Brad, do you want to follow up on that?
Yes. Can you hear me okay?
Yeah.
Yeah. So, yeah, I think, as we were discussing, we used to have Clang support, and yeah, I know there's discussion about, object testing, or, in adding new testing capabilities. But I think actually one of the things that's more important right now is just to make sure we don't allow memory errors, right? And run Clang and the address sanitizers consistently. I know that's one thing that we've, see as important internally. And then I have a second question also related to testing, back to the performance discussion. But first, I just want to kind of hear what other people think about trying to use the address sanitizers with Clang or Valgrind, or getting more robust just memory error testing.
So I'll say two things really fast on that. One, we support Clang up to 9 now. We tested, this took 2 weeks of testing for Bobby and Hua and a lot of my group here. Every single compiler from GCC 4.8 to GCC 9 and Clang something to Clang 9. Cross product with Python 3 and all the potential build options in gem5. And we fixed, I think, all of the build errors. So we should support all of that. We also ran Valgrind and didn't see any problems there as well offline. The address sanitizer and stuff in Clang is a great idea, though. Should be easier now.
Great. Yeah, I mean, I think for us, yeah, maybe it sounds like we just need to pull in some of those recent changes. But yeah, I think, we see the address sanitizers and Clang as a better option. We've been running Valgrind as well, and because it's so painful, we don't do it quite as often as we should. And yeah, it's, just having that robust support where we can make sure we can always run Clang on the tip. Sounds great. I mean, and I think that's one of the things we should definitely make sure. Is that in the public regression tester now? Is it in the suite? Is it in the automatic gates supported by Jenkins?
I'm not sure if I understand. Are you asking if Valgrind is in the automatic regeneration tests?
No, the address sanitizers in Clang. I understand Valgrind's painful.
Yeah, I don't think so, unless it's passed me by. I couldn't tell you exactly right now.
Okay,
unless someone else started it recently. No.
I don't think they are.
Yeah.
It's something that I've been running like manually, but I don't think they are in the testing system automatically.
Okay, but it sounds like with the work you did, it's fairly trivial to add, Bobby.
Yes, I would assume so. I've not added them myself. I don't think they've been added since. So.
Okay. Yeah. So I mean, I think that's one of those, like, the simple things we could do that I think would really make sure we maintain that good quality.
So I guess the question here is the runtime overhead and how much more runtime or how much more cluster time we can get from the test system. But I definitely support the idea of running the address sanitizer for at least a subset of all of the tests. And
yeah, yes, yeah.
We probably want the undefined behavior sanitizer as well.
Yeah.
Yeah.
Briefly say something about the testing infrastructure, so and the amount of time. So something like that, we'd probably run less than nightly, like nightly or less, either nightly or weekly. I think Bobby and I were talking about running all of the compilers weekly on the tip. Yeah, so the PMC needs to talk about how we're going to do testing long term. We have enough resources to do this kind of testing for 6 months to a year, but after that, we're going to have to think about other ways we can find resources for that. We don't have infinite testing capability.
Okay, yeah, well, let's bring that up. Yeah, we wouldn't run on everything, right? You'd have to find some isolated tests, some diversity, just to make sure you're getting some coverage.
Yeah.
Okay, well, that's great. Yeah, the other thing, on the testing side that I think was brought up a couple of times already is, performance regression, and I'm talking specifically simulated performance. The simulator performance is important too, but I would think simulated performance is probably even more important. Going back to the statistics discussion, right? We had at one point in time test on Zizzer that looked at large discrepancies in stats. It was good, but it was painful because a lot of times things would get flagged where somebody had no idea how to fix it. Why would their check-in change some ARM performance test, and I only warranted x86 and so forth. And so it was hard, but I think those kind of things we need to reestablish. And I think also part of the problem though is how do you integrate that in Jenkins? I mean, we have the same problem internally. Is Jenkins, it's very easy to write a test that says generating error code, right, if it fails, but how do you do these performance regression tests, and and whether you say you can't take any performance anomaly or you allow some in some ranges, and what stats you test, right? It's not an easy problem to solve, but I do think it's an important one to resurface and see if we can do something better.
So one thing we do internally for some of our internal simulators at ARM is that we track the simulated performance of a set of benchmarks over time. So nightly, there's a cron job that runs a bunch of different tests, and then there's a database commit IDs where the tests were run and all of the simulated performance. Now, that doesn't tell us that this specific commit broke something, but it does at least give you the trend and goes so you can like track big changes. And I suspect something like that could be plausible to do in Gem5 without too much work.
Yeah. I mean, so the code to support that would. So do you have it generate some, kind of website or some sort of output that you can view online?
So what we do internally for non-Gem5 simulators is that we have some sort of data graphing tool and a big data magic thing in our data center. I don't know how we do it for Gem5, to be honest.
Okay.
It would be quite interesting actually to have some sort of database for time series data, like InfluxDB, and some sort of graph analysis tool like Grafana or something like that, where for a set of very important benchmarks, you can just go through history and see how they develop, right? And I'm talking about some very, very high level metrics. So for a very, very totally specific configuration, how the IPC has changed, or how the miss ratio in the data class has changed. I think the previous stat framework where we were tracking this was overwhelmed by the amount of stats we were trying to correlate, and the fact that we were actually committing these stats with a Git repository, and it wasn't volatile enough, right? So every time we would change the baseline, we'd have to create a commit. And given the number of stats we had, this ended up being like every time we had a change, something would change because, fine. If you're checking every like nanosecond here and there, you might have like a simple change that will cause a storm of changes in stats.
So can I ask a question for those that seem to have something working here? Would it help if we're checking in the test a single stat? Or would it help if we used very directed tests? Like we had a test that we knew tested the issue width of the out of order CPU, and then that's the only test that we looked at the out of order CPU stats?
I think it would help a bit at least. So the problem with the old system was we tested everything with every single benchmark in, I think, spec 2000 or something. So if you change the memory controller, that would percolate through all of the architectures and all of the tests, and you had to run 8 or so different architectures to regenerate the stats, and that's not really workable for most people, especially since we don't distribute the spec binaries.
Yeah, so we removed all that from testing.
So something I've tried and it worked quite well. I was actually trying the latencies of the coherent crossbar. I sent in a packet and I expected to come out after a given number of cycles, and that's super easy, right? It's very simple, I understand it, and it's just one metric. So I think like on a sim object basis, we can devise sort of like tests, if not unit tests, which test some timing attributes. But it would be nice also like to close the loop and have some high level metrics as well. I think we need to do a little bit of both, and whichever like comes first is just going to be on the right direction and very, very useful.
And I think this sort of goes back to Jason's proposal for like well-known correlated configurations, which is sort of the other side of testing, where currently you might have a stable behavior, but you don't really know if that behavior is actually representative of anything useful. For example, if you use x86 and O3 CPU, the TSO implementation is kind of weird. So you get really weird store behavior, which I'm pretty sure isn't representative of what the AMD guys are doing or what the Intel guys are doing. And it's obviously not an issue for ARM because we're not TSO, we're closer to the original alpha model, but it's something that makes me really scared every time I see an x86 memory systems paper that uses gem5. On the CPU side, it should be said. Yeah.
Okay. Yep. Does that cover what you want to talk about, Brad? Are we ready to move on?
Yeah. I mean, just to maybe wrap that up, I think one of the things maybe if the website you were showing earlier about the health of the different combinations, if maybe the next step on that is actually maybe projecting some performance, some CPI or IPC for these different runs, and then just seeing how they track over and over. That'd be a great next step. Okay.
Yeah, thanks. Step we're going to take. Thank you, Brad.
Great.
Great. So let's see. Robert Henry asked, "Are we sharing any tooling with the QEMU community?" The quick answer is no, and I think that is mostly because QEMU is GPL. So it makes it very difficult for us to share anything with them since gem5 is BSD. That's unfortunately.
We should be able to share some tests, shouldn't we? We have a separate test repo now, don't we?
Yeah, now that we separated out the test repo, okay, we'll look into that again. It's been a while since we've done that. Yeah, but we certainly use QEMU a lot internally for checking things and stuff and setting things up. But yeah. Okay. Adarsh asks, the Ruby is of significant interest to several researchers, including us. Is there interest in improving Ruby to be integrated with trace CPUs beyond just the elastic trace CPU, say something like synchro trace? So Adarsh, are you able to use your mic? I would like to know what synchro trace is. I will assume that that is a no. They cannot use their mic. Oh, no worries. So I think generally, we hope Ruby can be used with anything which is a memory object. Okay, a couple of links to GitHub. Interesting. This is not something I have seen. We would be happy to take the contribution of Synchrotrace, assuming that it's improving things. That seems like a good idea. If that's something your group is working on, we'd be happy to talk to you about it for sure. Okay, so I think that's everything that's in the chat right now. Well, here's one. Sachin asks, as a beginner, can you recommend some GUI-based simulator to explore things more? No. There's the gem5 GUI, although I'm not sure if I would suggest it as a beginner right now. We're working on integrating it and can probably be improved. But yeah. Okay, so let's see, is Shrinkot on here? Because we have a question about Garnet. No, it does not look like Shrinkot's on here. Maybe Brad could say something about this quickly. What advancement does hetero Garnet have over Garnet 2.0? Brad?
Thank you.
There you are.
Yeah, sorry. I'm trying to do a couple things. It's early in the morning here. And that's why you don't have shrink hunt. This is way too early in the morning for shrink hunt. I can guarantee you that. But yeah, that's one of the problems with trying to have these things across the world. It's not a great time for everybody. Can't be a perfect time for everybody. But yeah, so in terms of hetero Garnet and one of the features there, so I believe Shrikant's talk is online, right? Right. It was posted yesterday. Oh, it was posted a few days ago, but it's in the workshop list that was presented yesterday. That does a far better job of getting into the details than I can. But effectively, you can think of it as a set of new objects for Garnet to be able to support heterogeneous chiplet-based interconnects. So in these large multi-chiplet NOCs, you're going to have many clock domains, many crossings between different link widths, and all that is now supported with hetero Garnet. Hopefully that helps provide an overview. Yep.
Let's see, there's something else. So Alex, I know you had your hand up a while ago. And so I assume this is the question you wanted to ask. Do you want to take over, Alex, and ask your question? Because I think that this is something that I would like to have a bit of a discussion on.
Yes, that was the question that I had, but I think people were raising their hands physically. So yeah, the motivation for this is we want to simulate many cores. So there are already multiple SoCs out there with 64, 80, 96 cores. And we want to simulate, of course, way more than that, hundreds, thousands of cores in a system. And just when we are going to 64, 128, it's already a problem simulation time. And doing a little bit of profiling on the performance of the simulator, we've seen that 90% of the time goes into O3 modeling. For many of the experiments that one wants to do, maybe are more focused on the system meaning interconnect, caches, and so on. But sometimes just using traffic generators is not the right thing to do. Or maybe using like just timing CPU is not the right thing to do. You want to see what are the effects of out of orderness, some prefetching that are many times important for performance. But a full-fledged, very detailed model like O3, it just takes too much simulation time, and it's too much. So like an intermediate core model that can have some out of order, still execution driven. I'm not talking about trace driven, which we can also talk about. Still execution driven, but that you can abstract maybe in a selective way parts of the model in the core, still functional, but you can abstract parts of it that maybe are less relevant for your specific workload that you're looking at. For example, in HPC codes, sometimes the front end is not that important. So maybe you want to abstract that part, just as an example. But there are no easy ways to do that in L3, I believe. And just going to timing is just losing too much fidelity. So having something that's in the middle and maybe configurable in terms of abstraction of the components of the core, we are seeing that you can have there like 2-3x simulation speed up just by reducing the time that you spend modeling the core, which it doesn't seem a lot, but if you are simulating for a week and instead of a week, it's 3 days, that's pretty good, right? Or 2 days, that's pretty good. So I think that's the motivation. And I would like to see if there are any projects out there targeting this more like an intermediate core model, or if there are any plans to work on it.
Yeah, I think that's a great question. And that is something that gem5 is missing. I think there's a couple of, so I guess I have 3 things to say to that. One, I think a short-term thing we could do is improve the timing simple CPU. I think there's a couple, I had a Krithika, who was a master's student here at Davis, was looking at the timing simple CPU, and she found some really low-hanging fruit to improve that. So I think that's one thing we could do in the short term. A little bit longer term, I had somebody working for a while on trying out on a more flexible CPU model that was out of order, but not cycle accurate like O3 tries to be. We were trying to give something that would let you choose how much parallelism you had in your core. But unfortunately, that turned out to not be very performant. It turns out if you're looking ahead in the instructions, that just takes a lot of extra time to do, generally. And the third thing I wanted to say was, I would still like to get the Flex CPU merged in that we were working on. I don't have any immediate plans for that. The third thing is other people. What are your feelings about this? And is anybody else working on new intermediate fidelity core models? I'll take that resounding silence as nobody else is working on intermediate fidelity core models. So maybe another question is, how does the community feel about the O3 CPU? Do we feel that that is a modeling modern out of order processors? It's close, it's terrible. How do we feel?
It's outdated.
It's outdated. Yes.
I saw Andres shaking his head as well. So I think we share feelings about that.
Yeah, I mean, if you look at any modeling core, you'll find features you can't model in gem5's O3 model, and things are done differently. I think pretty much every single core out there nowadays has some sort of micro-op cache, either for loops or something more generic than that. And that's not just CISC cores, that's really across the board for high performance cores. And I think there are other issues like prefetching modeling in gem5 isn't really that representative of what real cores do as well, especially in terms of how you train them. I think Nikos could probably complain a bit about the L1 interface as well.
Because did you want to go? I didn't mean to, but I did want to chime in here, especially because we have a lot of academic, contributors here. This is something that's really difficult for industry to add. I can say personally, there's no way AMD could update the O3 model and not be in a whole lot of hard IP issues. So this is, but something definitely academics. I completely agree. As was brought up before, the store performance in x86 is terrible. We've tried to make some changes on that that have been harder to get through, but even then, that's not gonna get it all the way there. It really needs a substantial update. And there's papers out there that tell you how current modern cores work. It's not super secretive. It's just not something industry labs can contribute.
Yeah. So what Brad said obviously applies to ARM as well. We generally don't contribute to the O3 model for that precise reason. So I think the work you've been doing, Jason, with the flexible approximate O3 model is very useful in that respect, because it means there's less detail but more flexibility. And because the O3 model isn't particularly accurate with respect to modern core, that might not have any real impact on the accuracy of your simulations at the end of the day, but it does give you more flexibility.
That was my thought with it when we started the project, and it needs to be finished.
We need it faster if you're going to make it simpler.
Yeah, that was, I was really disappointed to find out how slow it was. And with the code that we had, it wasn't clear. It wasn't 100% clear to me if it was slow because of the way we were doing things, where we had a lot of hash table lookups and a lot of maps and a lot of synchronization with smart pointers. So that could have been the overhead, or if it was like intrinsically what the overhead of trying to model an out of order CPU is going to be.
But if it's on par with the current O3 model, it's still fine. Because it's a different problem.
A performance fidelity curve, where high fidelity, it takes a long time, lower fidelity, and it's a more reasonable performance, or it's a faster performance. That would be ideal. Yeah. So another question related to that, for those of you who are more microarchitecture experts than I am, do we need to have ISA specific CPUs? Is it possible today to have a CPU model which is high performance for x86 and ARM and RISC-V, or do we need to specialize our CPU models for our ISAs? I feel like Gabe might have something to say here, since he worked a lot with the x86 ISA at least.
So I think we can do pretty well. There are going to be certain things like microcode, for instance, that aren't necessary in some circumstances and are essential in others. So you can't have x86 without microcode, but probably I'm going to just guess that with RISC-V you could do pretty well without microcode. So there's going to be some amount of overhead just by having the hooks in place so that you can have that functionality even if you're not using it. I think in something like an out of order CPU, that's probably still a small factor, but it's going to be dominated by other things like keeping track of all the instructions and checking for load store interactions and those sorts of things. I think while there's probably a small amount of performance you could eke out by making things specialized, you also, combinatorially explode the number of possible CPUs you can have, and it's difficult enough maintaining, I would say probably on average 3 CPUs. The exact number is larger or smaller depending on what you count. But let's say that somebody wanted to add support for RISC-V in whatever that would be in the future. If they have to do that and also implement a CPU, then that becomes prohibitively difficult. It's much easier to just implement the ISA, which is in itself a huge task, and then have it be picked up by existing CPU models. Now, that said, I would like to see specializations of the CPUs. So for instance, if you wanted to have an O3 CPU that executed the ARM ISA, you could have a model which was based in the O3 CPU, but then had small specializations which made it more appropriate for ARM. Like it was 95% common code, and then 5%, things were adjusted or subclassed slightly to be more ARM specific. But that's something I haven't thought deeply about as far as how it should be architected and how that should work. But I think that's kind of a middle point, which gets you most of the benefits and avoids most of the costs.
So I know that Gabe doesn't like the way this is done in the minor CPU, but the minor CPU actually does something along those lines, where it has it's almost like a small DSL in Python, where you describe the way you route instructions through different pipelines. And that's done by matching the bit pattern in a semi-decoded machine instruction in gem5. And that's inherently ISA-specific, but it's not just ISA-specific, because your instruction routing will also be core-specific. But I think that's sort of the middle ground that Gabe's looking for, but the implementation might be slightly different.
Yeah. And I think the problem there is just that the classification mechanism assumes that you can use a bit mask to classify instructions, which is not universally true.
Like x86.
Yeah.
You kind of can. It's just a very large bit mask.
If you know where to start.
Well, that's what I meant by half decoded instructions, because even ARM instructions can be either 16-bit or 32 bits. So what gem5 does is that it parses the instruction stream and then generates instruction objects that are half decoded. So you get like a well-defined value that you can route through the pipeline.
Yeah, it kind of canonicalizes the instruction. So it figures out what the immediate values are. With x86, with the variability of size instructions, it figures out what bytes are the instruction and which parts are which, and if there's specialization like a prefix that changes the operand size and all that kind of stuff.
Yeah. Okay, I think that this is good feedback. I think that both what Alex was saying about having a faster CPU model, which still gives us some fidelity, as well as having a more flexible and more up-to-date out-of-order model, are two things we should definitely work on. But it is difficult. So yeah, as Brad said, for those of you out there, grad students who are looking for interesting projects, I think that this would be a really good one. It'd be a big project, but it would be really, really helpful to the community to do. Yeah. Okay. Let's see. So I kind of want to move on. And there are a couple other topics I wanted to make sure to touch on that we mentioned yesterday during some of the talks. And one of them is support for large-scale PCIe devices. So I feel like a lot of this support should probably be shared between all ISAs. But right now, I don't think it is. So Brad, do you want to talk a little bit about this? Because I know that your group is working on this with the full system GPU stuff.
Sorry, yeah. So I think as I mentioned yesterday, we're working on full system support for our GPU model. And one of the key aspects of that is, current discrete GPUs, typically are connected to PCIe, and they have their own address spaces, but they're part of the same system. So to do that, we actually need to have effectively a separate physical address space that starts at address 0, but it's distinct from the host system address space. And so Matt Paremba has a patch out there that we've gone through a few times internally already, but he posted it externally to get other people's feedback on. But that's one step into this larger initiative to add more PCIe connected accelerators it's not just GPUs that I assume, have, separate discrete address spaces. And also, as I mentioned yesterday, this is the first, I think, truly PCIe attached device that's using, modern PCIe features like global atomics and large bar support. So that's also coming with these changes. I don't know, Jason, is that kind of the level of detail you want me to get to, or is there more you want me to discuss?
I think that's a good overview. So I guess one of the questions that I was interested about, because I mean, I knew that you guys were working on that, but from the ARM side, and also maybe Gabe, like, are there any, is ARM also thinking about these kinds of devices at all? And, I know Gabe did a lot of the device support for x86, and so I think having some feedback there might be a good idea too. That's first the ARM, or go ahead, Gabe.
So I have been thinking about this a little bit, just as far as not in specifically looking at devices, but in the address space aspect of things. Right now, we have kind of a global address space, and that is somewhat technically necessitated by the fact that the request objects, which track a memory access through its entire lifetime, have one field for virtual address and one field for physical address, and those get filled in at the beginning, and then they are referred to throughout the life of the transaction. I don't have a great answer, but I think one thing that would help make supporting those things easier is if the request object just had, the current address, which is relevant for the address space that you're in at in the moment, whether that's virtual address or physical address, or if you've been translated by an IOMMU, or if you're in a device-specific address space. But how to do that without adding a bunch of overhead and without making things really complicated is kind of the key question.
That's something we have been discussing internally at ARM. And one way of doing it would be to have like a stack where you push a new address on the stack every time you translate the packet or the request. The problem in many cases that we run into, well, we haven't actually implemented anything, but as a thought experiment, one of the issues we had was that it makes coherence really hard. So when you generate a snoop, you need to go backwards through some of the layers and generate different addresses in a way you don't usually generate addresses. So it makes your translations a bit tricky. I think it's something you can work around though. And we have some almost hackish ways of dealing with a linear address space in interleaved channels that use like a separate address class in gem5, but that's not a pretty solution. We should really have channel local addresses instead.
Yeah, so actually that's somewhat of what Matt's patch trying to accomplish is associating a network pointer. So each of these address spaces are effectively local to the network. So there's a local network pointer. And, with our work, we're very focused on Ruby, and one of the things, supporting functional accesses in Ruby and so forth. When these request packets, and Ruby requests get generated, they have a network pointer associated with them. That physical address is relative to the network. When you want to do a functional access, it's a relative to that network. So that's the solution that's out there. Yes, it seemed like the best option, especially considering keeping the code changes relatively simple. One could we've done this, or we've tried it at least, doing this whole separate Ruby system, but that just turns into a monster amount of changes where you touch pretty much every file. So yeah, as you see Matt's patch, it's much more of an isolated change when you just have to effectively provide a local network pointer instead.
Yeah, I think the channel local addresses idea is generally important. I think that's something that we need in a number of different places right now. So another one that we ran into with x86 is the big IO hole, which makes, like, you need channel local addresses to deal with that IO hole as well. There's some kind of translation going on there. I don't fully understand what hardware does. But.
So there is a channel local address class in gem5 now, but that's specifically designed for channel interleaving. And so if you want to have a device that is per channel in your memory system, you can translate into a channel local address and treat it as a flat address space. And then when you create a new request from that object, you can translate it back to a global address.
We'll have to look into that. The difficulty with the interleaving is we need holes, right? And to interleave across holes, which is difficult.
That's actually a challenge for a lot of the systems we want to model, because the ARM memory map is usually, you usually don't have this nice flat address space, which is your DRAM. It's usually split across multiple regions because you have like a backwards compatible region somewhere, and that's below 4 gigabytes. And then you have the rest of the memory somewhere else. And oh, it turned out we need a couple more bits. So there's another chunk somewhere else. And that's really hard to model in gem5.
So does your the channel local address successfully model that, or do we need to add more capabilities there?
It doesn't solve that problem. It's mainly just solving the interleaving issue. So the reason I designed this was because I needed a way to reason about a flat address space within a channel for an encryption and integrity engine, a bit like the kind of integrity engine you find in SGX.
Okay, great. This is something I will take the action item of bringing this up soon in Jira and other places.
It gets particularly complicated if we talk about interleaving in the caches, because the caches have to, so if you think about like modeling a specific level in the cache as having like multiple banks or multiple slices, you have to understand interleaving from requests that come from the memory upwards, and also like merging those interleavings and rebuilding the address when you send downstream requests. So I think the channel address works quite well when we're talking about the final stage of a request, like the DRAM controller, because the DRAM controller will only accept requests and send responses upwards. It gets extremely complicated when we're in the middle and we have to split the address stream into different objects and then merge it again.
I think you could actually use the channel address for the cache though, because all it does is it takes your address range and an address and then creates a linear address within the current channel. And then when you create a new packet, you do the opposite.
Yeah, but you could. If you have this information, you could. If the channel address is built in the coherent crossbar or upwards from the cache and you're not aware in which slice you are, then you're missing out information, right?
Yeah, that would be hard.
But I mean, as a type is good. I think we're just missing some of the logic there to just put everything together and do it for the cache.
Cool, great, thanks. That was a good conversation. So Brad, do you think that addresses most of the things that you all are running into with the PCIe stuff, or is there, I don't know, maybe, I guess I never heard an answer from the ARM people about, do you all care about true PCIe devices?
It's something we care about, but it's not high on the list of things we care about. The main use case for gem5 at the moment is client systems. So for ARM, that means typically systems that don't have PCI at the moment. We have done some server revelations as well, and there it would make more sense to have PCIe. But given, I mean, of the things I care about, I probably care more about some of the fidelity issues we see and lack of of architecture support in some corners of the ARM architecture. At the moment, that is.
Yeah, I guess, I know other people, see a few people on this call, and certainly other people I've talked to that use gem5 are thinking more and more about ARM in HPC, which I imagine is where the PCIe stuff would really start to matter.
Yeah, so you probably want to use PCIe for a high performance NIC, for example. Depending on what you're doing, you might be able to get away with the VirtIO model if you don't care about the IO aspect of the experiment and only care about the CPU side.
Yeah. I imagine high performance NICs and of course GPUs.
Yeah.
Yeah. Okay, great. Anybody have anything else there about PCIe devices or other new kinds of devices to integrate? Okay. I realized that this has been more the somewhat main developers talking. I was hoping to hear more from people I've never heard before. So let me ask a more general question of the community, where I really want to hear from everybody. What workloads do you care about running in gem5? Do you want to run HPC style workloads, desktop style workloads, spec? Is that all you care about? Is it, I know a couple of people were mentioning in the chat, Android, some mobile workloads. But what kind of workloads are most important to your research? Sachin says spec 2017. Okay, so spec and MI bench. Junhino. Rodinia. Okay, so mostly desktop and then a little bit of mobile kind of workload.
Yeah, one thing I wanted to mention that's a little bit challenging is server workloads in which you may have a client and there may be, I don't know if there are already solutions that are like selected as the best way to do it. So you want to model the server chip, but the requests come from some client. And what is the experience of the community on modeling these kind of setups?
That's a really good point. That's something that I know GEMS supported really well, and gem5 has supported in the past. I don't think, there's certainly not good documentation on that right now. And Abhishek Singh on YouTube also mentioned transactional workloads, which is similar.
So I think traditionally gem5 has supported running multiple systems within the same simulator and then use virtual network links between the systems. And you're even supposed to be able to run the systems on different host threads, so you get some amount of parallelism between the simulated threads of simulated systems.
Yeah, I think that traditionally that's been supported. I'm not sure if it works right now. I know we don't have any tests for it, so it's unlikely that it's going to work out of the box right now. But that's something that I've written down as something to start testing.
Yeah, I think what I'm asking is there a simpler way to model that behavior without having to actually simulate two systems? If you're more interested on the server side, for example.
Yeah.
From the timing perspective, I mean, you're interested on the server side from the timing perspective. Are there solutions to model the client without having to model a full second system for the client?
Yeah, I think I've given a little bit of thought to this, and the answer is that straight out of the box, not easily. We have a network model that in theory can actually connect to the outside network. So you could have a client running on the host and then connecting via the network. I think the KVM model would be really interesting, to where your second system is running in KVM and driving the timing system. That would be a very interesting thing to try to get to work. Andreas is making faces, so
No, it's interesting, as in it would work, I think, but it would be hard.
Right. Part of your simulator in timing mode and the other part in KVM mode would be interesting. Or like I can imagine even having, if your client is a simple traffic generator, like you could potentially have that written in Python and having the Python driving a network model. And just have any kind of, you could then run a separate program on your host that just has a socket that connects to that Python server inside Gem5. There are a lot of different ways to do it. I don't think anything immediately works out of the box right now.
Yeah.
But I think that's a good important direction to go. So I also see Shahab is using multi-threaded benchmarks like Parsec, Splash, and Graph benchmarks. I guess I have a question for Shahab with those. What scale are you interested in? Are you interested in the desktop single socket scale where it's only 8, maybe 16 cores? Or are you more interested in the server HPC scale where you have 32, 64, maybe even 128 cores all in a single system?
So I'm hoping to get to 64, but yeah, as you can expect, I'm running into runtime issues. It just takes forever. So I think the results I've got so far are for 16. I'm hoping to be able to run 32 and 64, but I'm not sure if I'll be able to.
Okay, yeah, I think that makes sense. That's also problems we've run into in our research group as well, that getting things to work beyond 16 cores is difficult. So that's something we'll take into account and try to improve on for sure.
Thanks.
So let's see. Abhishek asked an interesting question on YouTube, which is, going forward, will we consider dropping SE mode and only have full system mode? I don't think there's any plans to drop SE mode, although I agree that it's important to be supporting full system mode. SE mode is really nice for testing and debugging and testing out a new system. I'm hoping with some of the Gem5 art stuff and the Gem5 resources that we're putting together that full system mode will become easier and easier to use. But it's still going to have an overhead. Booting the kernel, even in KVM mode, takes minutes, seconds to minutes, which is an overhead to running a quick little test to see if something works. So yeah, that's a great question, though.
And one thing that I'll toss in there is that I would like to, in the future, it's a long-term project, but make SE mode and FS mode share more stuff, so that SE mode is lower overhead maintenance-wise and otherwise.
Yeah, definitely. And I think, the work that Brandon Potter put into SE mode over the last few years really has improved it a lot and made it more useful than it was before, especially the support for dynamically loading libraries makes it much easier to use and more useful.
Yeah, the one thing I would add, though, is we need to work on the determinism in using SE mode. That's one of the things that definitely has been a struggle for us. Is it's deterministic only on the machine you run it on. Yeah, when you start linking to the host and you rely on the host to do a lot of those system calls, you take in all the non-determinism of real systems, especially timing wise. I mean, that's the key. So yeah, no, I mean, obviously, I'm biased. It was tremendously helpful for us. We've been using that over several years internally, as you said, to really do research on the cutting edge of applications. You have to support dynamic linking in SE mode. But yeah, there is that cost that I think, to me, was the obvious thing if we want to improve the SE mode support, is getting better support for deterministic execution would be a primary goal.
Docker, use Docker.
So maybe, well, Docker wouldn't really solve it though, because you're running on the host kernel. So
that's true, you're right.
Then maybe a way of solving that would be to run something like user mode Linux within FS mode and then fake a syscall emulation mode using a real Linux kernel and use some sort of loopback file system like 9p to mount files on your host. And that way you kind of get a hybrid solution.
That sounds like a lot of work.
Not necessarily. Another option that has been used for benchmarking in the past is to put benchmarks in something that looks like an int.rd and run without any real disks in the system or any sophisticated devices. Sort of achieves the same thing.
I would still need to boot the kernel though.
Yeah, but you can use a fairly small kernel because you don't need that many drivers. So that should be quick, even on Atomic or O3.
Yeah. Okay, cool. So we only have a couple minutes left. Does anybody have any last things that they wanted to get in here before I wrap up? Okay, great. So thank you so much for joining. Thank you for inviting me into your homes, because I know everybody is at home right now. Let me know. I'll try to send out a survey after this, because I kind of would like to know how this went and whether people feel like this was useful or not. And if people do feel like this is useful, I will try to do this more often. So yeah, thank you so much for joining. I'm really excited about the future of gem5. Thank you all for being part of the community and everything that you've done for gem5 so far. And I look forward to seeing more contributions from all of you here and everybody in the broader gem5 community in the years to come. So thanks so much for joining.
Hey, and by the way, well, that's everybody. Let's thank Jason for all the work he's put into this. Definitely, I think we are, very blessed to have you, put so much of your time into the, this community infrastructure, Jason. Definitely appreciate it.
Thanks, Brad, and thanks everybody else. All right, well, I'll see you all later.
Yeah. Thanks, Jason. Thank you.
Hopefully in person next time.
Thank you, Jason. Thank you all. Bye.
Thanks.